Today I'll discuss earthquake dataset of 100 years, which is in the CSV format, and the big data. This is one of the big data. So let us understand a little bit of big data. What is big data is? Big data is actually high volume, high variety, and high velocity of information, which is structure, semi-structure, and unstructured collection of massive data, and that grow exponentially over the time. This is a simple definition of big data. To understand a little more of big data, let us try to understand 5 characteristics of big data. That is, first B is volume. Volume refers to the high amount of data, maybe in the form of terabytes, petabytes, zettabytes, etc. So velocity is second B of the big data. That is, velocity is basically refers to the speed of data that is created and how fast it moves. Very fastly data is moving in hourly basis, daily basis. Okay, so that is velocity. Third B is variety. Variety is the diversity that exists in the types of data. Heterogeneous type of data, that is maybe in social media, images, audio files, etc. The fourth B is veracity. It is the basically deals with the quality of data and how accurate data is. There may be a lot of inconsistencies in data. That is inconsistencies, error, like data duplicacy, missing data, then high latencies, etc. Then data usefulness, in that case it erodes quickly. So last B is value. So how we can draw the information insight from the data, that is actionable insight from the large data, is considered as a value of the data. So let us try to draw some actionable insight from earthquake data set of 100 years, that is 1921 to 2020. So let me connect the data set quickly. So this is the earthquake data set, real data set of 100 years. Open quickly. So this is data, as you can see by seeing these rows and columns, large number of rows and columns. We will not be able to dig out the important informations or actionable insight from this data set. So how many data? Let me say quickly. So yes, we can see from this there are 3,282 rows in this data. So quickly try to find out the actionable information from this data set. So this is the data. So let me drag firstly here. So here is a discrete. So let me click here, discrete, then magnitude here. So I'm trying to find out years and magnitudes comparisons. Compare which year the magnitude was high, low, etc. When tsunami was happened, which year. So that way I'll try to find out the insightfulness of this given data sets. Okay, so now I'll make the this into bar graph into shape, because this is, in this way we will not be able to make out any information. So shape, click here. Then again here is coming, then magnitude is not coming. So let me click this magnitude. Magnitude is maximum. Okay, so measure, go to the measure and click maximum. This will come up. Now a little bit information I'm getting, more information. Two basic information. Year 1922 and 8.7. Quickly change this title bar. That is, I can say 1 century data. Earthquake data visualization. Apply. Okay, so done. So this part is done. So next would be, I'll try to change this shape into this ball. Okay, so I'll try to change the location, add the location name into the label, so that which location it happened. So where is the location here in this data? Location name, yes, into this label. So once I've added this, the location name as well as here is coming here this way. So let me uncheck this label. Okay, it is done. Then add the location name. Then what else I can do? Shape I've changed. Then put the magnitude into size button. Where is the magnitude? Magnitude into size button. So a little bit, it's not, size is becoming less. Then make it the maximum. Go to the measure and then maximum. Okay, all right. Now as I can see, the earthquake happened in Japan 1933. That was magnitude 8.4 in Richter scale. So but I am not able to see which date it happened. So let me put the day of occurrence here. So to do that, you have to click here, create field. Okay, so add day of occurrence. So more insight, I have to know day of occurrence. Then make date. Then yes, year. Click here directly from here. You can use, then put comma, month, automatically displaying here. YYY, MMM, and the DY. So month is coming. Click. Then again day. So done. Okay. So day of occurrence I have to drag again to the level field. Which date it happened? So actually, yes. Again, this is not coming. Day of occurrence. they have to click exact date so that I can see the day of occurrence. Yes. Then uncheck label mark, show mark label, uncheck this. So now more information is coming up. This, let me check this. In Russia, yes, date is coming 4 November 1952. It happened in Russia. Very high magnitude, that is 0.99 Richter scale. So this way I can visualize this as one is, this is the highest one, as I can see this is the highest so far recorded, that is 22 May 1960, Chile, Porto Montt, Valdivia. So this is the place it was actually happened. This is the real data set, as I said, 9.5, very heavy destruction. So this way I can view date, hour, also time I can also that edit, but for today, so whether it's happened tsunami along with this, let me add like tsunami to level here, then yes or no, is no tsunami happen, yes or no, it is coming, yes, tsunami happen, Turkey, yes, 3 May 1928, along with tsunami it happened. Okay, so this way, so again uncheck this, so mark. Okay, so now this is same color, let me change this color by adding magnitude, and I can make it to discrete. Magnitude add from here also I can drag, I think, yeah, this is short magnitude, then make it to discrete. Yes, this is more clarity of visualization. So here this is in Russia. This is highest recorded. Russia is second. This is the second highest where it is happened. 28 March 1964, Alaska. So this way visualization can be done very easily, friends. So any data, visualization of data is very, very important for quick decision making for any organization. Nowadays we have numerous data, big data is there, so we can do visualization very easily by using tools like Tableau, Power BI. So this is for today, and please